Okay, welcome to Friday's lesson on finding the area, surface area of prisms. Okay, so basically what it boils down to when we're finding the surface area of a 3D object is we learned yesterday, like something like this box that we learned is called a rectangular prism, has 6 faces. Okay, in this case it's got these 4 rectangular faces, right, that are all the same size, and then it's got these 2 square faces on both sides. So it's a total of 6 faces, the 4 rectangles and the 2 squares. Hopefully you see that. Okay. If you can find the area of each flat 2-dimensional side and then add them up, that's the easiest way to do it. That's what it says is method 1, and this is the one I recommend. The only reason I show you method 2 is it helps us when we get into cylinders. Okay, it's going to be a trickier thing because you can see with a cylinder you don't have these unique rectangles on the sides, you just have this one continuous curved surface. So I'll show you tomorrow how we can tackle a problem with the cylinder here. And knowing this second method will kind of help us with that. So I again would not recommend method 2 for today. It's trickier, but to show you it, it'll help you understand where when we do cylinders tomorrow. So the surface area of any prism is equal to 2 capital B, the area of the base, plus the perimeter of the base times the height of the prism. And the height of the prism is the distance between the bases. So with a rectangular prism, it can be any one of the sides that you consider to be the base. You can, as long as you, like if I put my fingers on these 2 rectangle sides here, so you can see my thumb and finger on those sides. If you looked at the distance between my thumb and finger, that would be what I'd consider the height of this prism if I considered those sides the bases. So if instead I said the squares, if I hold it like this and I say the squares are the bases, then that longer distance would be the height of the prism, the distance between the bases. So that can be a little bit confusing, which is why I don't recommend that. I will go over it again tomorrow with the cylinder and it'll probably make a little bit more sense. But again, the main reason I'm showing this is so that the cylinder formula doesn't come out of thin air tomorrow. Okay, so for today, just find the area of all the faces and add them up. I think that's the easiest way to do these problems. By the way, I'll also show you real quick if anybody's interested in how to draw these shapes when you're doing the problems yourself. There's a couple different ways to do it. When you're drawing a rectangular prism, I think one of the easier ways to do it is to draw a rectangle like this, and then to go ahead and draw another rectangle overlapping it with the bottom corner basically right here in the middle of your other rectangle. You can adjust it, doesn't have to be in the middle. But a hint is try to make it about the same size as the front one, but I'm going to make these 2 sides dotted. And I'll make these sides solid. And then connect the front corner to the back corner on the 2 rectangles, and where the 2 dotted lines meet, make another dotted line. Ta-da, there's your 3-dimensional rectangular prism. If you're going to do a triangular prism, you can do a regular triangle. I think it's a little bit easier to do a right triangular prism. You do a right triangular prism, I think a little bit easier. Kind of works the same way. I'm just going to make my 2 sides that make my right angle dotted. And there's my right triangular prism there. Okay, so there's, if you're interested in being able to draw those shapes. By the way, if you make the lines solid, That's the old transparent cube where it if you draw all of them solid, then you can change the perspective of different sides depending on how you look at it. It can look like the top or the bottom of it, so it can be a little bit of like a visual trick on your eyes if you don't make them dotted. So you can do them solid too. Then it's just kind of like the transparent cube instead of trying to draw three-dimensional like this. All right, so let's look at example 1 here. Example 1, it's already drawn for you. You have a rectangular prism. So if this side is 10, by the way, you also know that side is 10, and that side is 10, and this side is 10 here, right? If this is 5, then you know this is 5, and you know this is 5, okay, all the way around. And if this is 8, this is 8, this is 8, and so on. So they're all rectangles. The nice thing is the front and the back rectangles are the same, the left and the right rectangles are the same, and the top and the bottom rectangles are the same. So you really, even though there's 6 faces, you're only doing 3 calculations. So you can see that the front rectangle is 10 by 5. So the area is 10 times 5, which is 50. Well, the back rectangle you can see is 10 by 5 also. That's also 50. So the front is 50 centimeters squared. The back is 50 centimeters squared. The left side is going to be, this is 8, just like all the other sides going back, like that. So that's going to be 8 by 5. 8 times 5 is 40. So if the left is 40, the right is also 8 by 5, which is 40. Then you got the top and the bottom. Well, the top is 8 by 10. 8 by 10. 8 times 10 is 80. These are all centimeters squared. And the bottom is also 10 by 8, which is 80. So now I have all 6 areas that I'm circling right now, and if I just add up those 6 areas, you get 340 square centimeters of my surface area. So it's the area of all the outside of that 3-dimensional object. Okay? If you take a look at the triangular prism here, it's a little bit trickier. The easier ones are the rectangles, because rectangles are still just base times height. So you can see my bottom rectangle is 3 by 10, which is 30. The left rectangle is 4 by 10, because these ones between the triangles are all 10. That would be considered the height of this triangular prism is 10, the distance between the triangles. 4 times 10, and then you have this diagonal rectangle here that's 5 by 10, which is 50. So there's all my areas of my rectangles, and then the only other thing to do is to find the area of my triangle. Okay, well the triangle, the area of a triangle formula, remember, is it's written right here, base times height divided by 2. Now this is where it gets tricky. Like I said, the height of the prism is 10. That's the 3-dimensional height is 10. But when I'm doing this problem right here that I'm going to box in, I'm going to use a different color. I'm going to box it in purple here. When I'm doing this problem right here, this is a 2-dimensional calculation I'm doing right here. So when I'm doing this, it's like its own separate problem. I'm just finding the area of this front triangle. I can ignore everything else. Right now I'm just finding the area of that front triangle. Well, the base times the height of that front triangle, you'd consider the base is 3. The height is the 90-degree distance to the top. Okay, so that's going to be 4. So I get 3 times 4 divided by 2. Well, 3 times 4 is 12. 12 divided by 2 is 6. So the area of this front triangle is 6. And the nice thing is that the back triangle is the same triangle. This is also 3, and this is also 4. So when you do that same calculation, you also get 6. So I just add up my 6 square centimeters to my other 6 square centimeters to my 30 square centimeters, 40 square centimeters, and 50 square centimeters. And if I add up 6, 6, 30, 40, and 50, I get the surface area is equal to 132 centimeters squared. Okay? So you have surface area of a rectangular prism, adding up the 6 faces, the area of the 6 faces. And then for a triangular prism, you have 5 faces, so you would find the area of all 5 faces and add those 5 areas up. Okay? boils down to, can you find the area of a rectangle repeatedly? And for a triangular prism, can you find the area of 3 rectangles and then find the area of the 2 triangles, which they're the same area. Okay? That is how to find the surface area of prisms. It looks like on page 10, I just have surface area of rectangular prisms. I don't have triangular ones on there. We mix up on the next couple of pages. I mix in a few more triangular prisms once we get cylinders in there too. But to make things easier to start, you just have examples like example 1 to start. So why don't you just do, change it up a little bit, and I'll have you just do about the first 3, 1, 2, and 3. Okay, do the first 3 areas on page 10 to try there. So find the surface area of each one of those 3 rectangles. I think you can see all the numbers pretty clearly. 9, 3, 13, 6, 20, and 4, 16, 5, and 14. Alright, so there's all those numbers. Good luck trying those. Have a great weekend, and I will talk to you on Monday. Bye.